Hey guys, January 18th, 2019. I have the paper here, Gravitational Collapse and Mass and Energy Loss Phenomenon. Um, what I wanted to get across with this paper is pretty straightforward, but very complex at the same time. Gravitational collapse is when an object is really big, it has a large gravitational field, and it collapses on itself. So take a really big hot object like the sun and you crush it. The sun crushes itself and it releases heat and energy and it loses mass as it does it. So it gravitationally collapses on itself very slowly over many millions of years. That being said, gravitational collapse is a mass and energy loss phenomenon, meaning when you have something collapsing, it's losing mass and it's losing energy. This paper, the purpose of this paper is to show that you cannot have something gravitationally collapse if there's not a lot of mass or energy present to allow the object to collapse. For instance, I have a little illustration here. I'll link this to the bottom. But you have a large object. Here's a young, hot, large star, and then you have a giant dust pebble cloud. And this is astrophysical dogma, and this is stellar metamorphosis. See, I have written here: the young, hot, big star collapses into something like the Earth, right in the bottom. But the dogma has a big dust cloud collapsing into the Earth. So basically, the problems with it, I'll go ahead and read out this to you guys. On this side, you have Earth as gravitational object. The star is the gravitational object to gravitationally collapse. 2, lots of mass and energy to fuel the collapse. And 3, the planet is the less energetic, less massive end result. And that makes a lot of sense. When you have something collapsing, it's losing mass, it's losing energy, it's losing light, and it becomes something that's less massive, less energetic. But the dogma, what they say is a big dust cloud collapses and there's no gravitational field there. So here we go. There's no gravitational object present. It's just a large dust pebble cloud. There's nothing there to collapse. It's just a big dust pebble cloud. There's little energy, heat, and mass to fuel the collapse. There's no heat and energy here. Where's all the heat and energy? It's already been dissipated. They're just rocks that are just floating around in outer space. There's nothing to do any work. And the planet, they have the planet as the more energetic, more massive end result. So all the small pebbles clump together to make one singular object. And that doesn't make any sense because this is vastly more energetic and massive than all of this. But when you have something gravitationally collapse, it forms the planet in the interior and it loses the mass and energy as the gravitational energy is being converted into heat and light, which means after many billions of years of converting that gravitational potential energy into heat and light, it loses its ability to shine and it loses its mass and it becomes something that's less massive and less energetic and no longer shines. That's very difficult. That's very difficult for astronomers to grasp. They don't like the idea that gravitation can't be used as a hammer. And the saying is, when when you have a hammer, everything looks like a nail. And that's basically what they're doing with gravitation. And I know Electric Universe has called them out on it on multiple occasions. You can't make a gas in the vacuum of outer space collapse on itself because the gas will naturally expand. That's why we see things such as nebulas. That's why, you know, we see, Saturn with its rings. If gravitation caused things to make round objects by itself, there would be no rings around Saturn. There would be no rings at all. There would be no giant nebulas. Everything would just be a bunch of grapes stuck together. There wouldn't be independent objects. Clearly, gravitation is only one tool in the toolbox of astronomy and astrophysics. But the astronomers, they overuse that single tool, and they think it can be used in all occasions, in which case it cannot. To form a star, you need something much more powerful than gravitation, and you need something that's a lot stranger, I would say, than gravitation. Even though gravitation to me is still pretty strange. And here I have a little diagram here. I'll link this to the bottom so you guys can see all of it. Stellar metamorphosis on the left, astrophysical doubling on the right. So we observe stars that have gravitationally collapsed and lost mass and energy. We've seen this observed with empirical data from telescopes, which means gravitational collapse, lose mass and energy. There's no contradiction there. The objects that have lost their mass and energy have gravitationally collapsed. That's what planet formation is from the hotter stellar past. Astrophysical dogma, they say, give dust and pebble clouds the ability to both gravitationally collapse and gain mass and energy, not observed. So not only do they gravitationally collapse to form the planet, remember from the first diagram where there's a large dust pebble cloud? Well, there's a large dust pebble cloud, so it gravitationally collapses, which means it loses mass and energy, but then it somehow also gains mass and energy to become the more energetic, more massive planet. And a really major contradiction. You can't have gravitational collapse happening in terms of, it's losing, something's losing mass and energy because the gravitational potential energy is being converted into friction and thermochemical and electrochemical reactions inside the star as it's collapsing on itself. You can't lose energy due to this process and also use the same concept of gravitational collapse to make things get more massive and hotter at the same time. And I think it's kind of strange because this all applies to planet formation in the vacuum. And that's one of the major weaknesses that astronomers and astrophysicists have, is they think gravity by itself can make something the size of the Earth. And it's not really high quality reasoning. Anyways, I don't want to make this talk too long, but I'll link this to the bottom, and just make sure to think about that, because to me still gravity is quite a mystery. How it actually works. And that's the basics of why I've been doing this from the beginning. I was trying to figure out what caused gravitation, like what's the real deal, what's the truth about all of this, what are scientists believing that are getting in the way of them understanding nature? What are their assumptions? And that's what I was digging at since I was like 11, 12 years old. And then I just stumbled upon, Earth being an ancient star, and then I went in that direction. But still, you got to really, the purpose of this is you got to really understand what gravity actually can do in order to understand what is actually causing it. You just can't make gravity do things it doesn't do, because then you try to take those ideas and clump them all together, and then it just confuses you even more. It's like, I don't know. You can't apply mechanisms using a force that never actually happened in nature, and then try to figure out how it works with all these strange things that you've invented and attached to it, because it's just gonna make things nearly impossible to understand altogether. I guess you could say a good analogy would be like, if you have like a 1,000-piece puzzle and you have 6 or 7 other 1,000-piece puzzles, and they're all from different manufacturers, and they're all different pictures, and you just can't take all those puzzle pieces just because they're puzzle pieces and mash them together. That isn't how it works. You have to separate which puzzle pieces belong to which puzzle first, and then you solve the puzzle. That's the problem with gravitation these days with astronomers, is that they're taking gravitation, which is a specific puzzle, and they're thinking that it applies to all these other puzzles as well. And that's where they're confusing a lot of natural phenomena, and that's where they're confusing themselves for the most part. They're good. Okay, they're good at compartmentalizing, just not good enough at compartmentalizing, if you will. They're good at chopping things down into little bits and pieces and deconstructing everything, but they're not good at using that deconstruction process and taking things down and breaking them up to little bits and pieces where it actually matters, because of, groupthink and all that stuff. So it's really strange. I mean, I guess I could talk like 30 minutes on that, but I'm not going to do that to you guys. All right, you guys, I'll link this to the bottom later.